Hello, eighth graders. So today I am gone, but we're still going to kind of venture on in our notebooks. And so I'm going to have you make sure that you get yours out of your tray there. Um, and go ahead and go to a new page and write Investigation 5.1 Earth Slayers. As you're doing that, you'll notice that we kind of skipped a couple investigations, 3 and 4 specifically. I kind of told you I was going to be doing that so we can get in a couple different things before we take the MCA. So some of those things we might come back to afterwards, but we need to kind of talk a little bit about some other topics here. So investigation 5.1, Earth Slayers. All right. Now, for this focus question here, we have talked about igneous rocks before, and so you may have somewhat of an answer to this question here. But our focus question is going to be, how do igneous rocks form? All right, so you're going to put your before answer there and your after, leave space for your after answer. How do igneous rocks form? After you go ahead and write that question down, go ahead and write your answer in there. And I'll let the teacher pause the video here for you until everyone has that done. Okay. So after you have your before answer done and you have written your space for your after, go ahead and do a separation line like we usually do. All right. And for today, I'm actually going to be having you guys do some observations of some new rocks. These are going to be rocks that are different from the sedimentary rocks that we've seen and looked at so far, but you will still have those to kind of compare to. So I'll start off first by having you guys replicate this table here underneath that separation line. Okay, so I'll kind of pull this all up here for you. So underneath your separation line, you should have a table that looks like this. I'm going to zoom out just a little bit more. Okay. So new rocks observation. So that should be the title that you have up at the top. And then you're going to go ahead and make a 3-column chart. You want your biggest column to be the observations one. So go ahead and, make the box all the way across your paper. You definitely want like 2 lines for like all these rock numbers here. So I would put the number 11 on a line and then make sure you leave a space before you put this black line between, 11 and 12. All right. So make sure that you separate these each by at least 2 lines. You could do up to 3 if you wanted to. For your headings, you have rock number. We're also going to be putting the name under here, so that's why I want you to leave a space. Observations. So you need to tell me what are the color, what is the texture like. You need to list at least 3 observations. 3 observations by just looking at it, touching it, feeling it. You can tell me the colors. You can tell me the texture. You can tell me what does it, kind of look like, feel like. Does it have anything special on it, as far as compared to things that you've kind of seen before. So look for those things to write down at least 3 observations for each one. And then you're also going to be doing the acid test. So you'll want to write down a column for that. And for the acid test, you're just going to put yes or no. So I just put Y/N here in the box. So I'm going to have your teacher pause the video here so you can finish making this box and they can restart it when everybody is done. Okay, so you should have your chart done here, again, leaving space to write things in. You are going to be getting your supplies from this, part of the room right here, okay? So Lab Station 5, kind of back where you pass by to get all your trays and stuff like that. You guys are going to be grabbing the rocks from these containers here. Remember that they're not going to close all the way most of the time, so do not force them closed. Just leave them half shut like this, okay? In addition to grabbing a box of the rocks, you're going to need a bottle of acid from here. And then if you want some magnifying glasses here, you can grab up to 2 for you and your partner. And then grab 1 paper towel here to sort of rinse things off. Oh, by the way, also in this picture, there are those glasses, those watch glasses. Those are those glass sort of little dishes that we use to put these on, to put the rocks on. So a couple things. I just have like 9, I think, sample boxes here. So you're going to have to, if somebody is, sitting right next to you, that's your group. If you're sitting on the side of the table by yourself, find somebody else who's by themselves and you guys can form a group of 2. So I just don't have enough for every table to have 2 boxes. So some sides of the table that just have 1 person will have to group up, okay, with somebody else. So there's only 9 available for you there. I don't want groups of 3. That's too much, not enough for people to do. So groups of 2. And make sure, like I said, you grab a bottle of that acid and 1 of those watch glasses. Now, when you are putting the drops of acid on the rocks, remember that I want the sticker side up, all right? And you barely have to turn the bottle over and it will come out. Make sure that when you put it on there, it runs down so it's not going to run into anything. All right, and you can use this to sort of dry it off before you put it back. Now, when you get your box, you're going to see it'll look like this, okay? These are your 3 new rocks. You have 11 right here, 12 right here, and 16 right here. Okay, so 11, 12, and 16. Those are your 3 new rocks that you're going to make observations about. These rocks are all set up the same way in everybody else's. These are all of our sedimentary rocks from the Grand Canyon, 10, 9, 8, 7, 6, 5, and 4 that we covered. All right, so these ones, you can just kind of have as comparison, but please leave them in this order. They shouldn't really be taken out. I don't want you to do any tests on these. Just leave them as they are. I just want you to do tests on 11, 12, and 16. Remember, sticker side up, okay? And one last thing, after you do your testing and you do your cleanup, some of you like to wash your hands because of the acid, and I told you to be careful. You don't want to rub your eyes after that. Everybody in the room needs to use lab station number 1 to wash their hands. I have lots of papers around the room for other students' work from some of my other classes, and the sinks get wild with paper or wild with water. So please, I don't want anybody using any sink but lab station number 1. That's the one where my fridge is by, right underneath the periodic table. Use this sink only to wash your hands. There's soap and paper towels there, okay? So only use this sink to wash your hands. All right, so that being said, I'm going to let you guys go ahead. We can pause the video here. You guys can do your observations, do your acid test with each of these, and then the teacher will restart the video once you guys are done with that. It should take no more than, 7 minutes or so for you guys to do everything and get the cleanup. You only have 3 rocks to test. So you can pause the video here. All right. So after you've done your tests, we want to just go ahead and put down some things that we should notice about these and also name these rocks here just to get a feel for them. So rock number 11, that's the one that has the kind of, black and pink sort of crystally like appearance. And a lot of you may have guessed the name of this rock, but I'll have you go ahead and write it down here. That rock is granite. Oops. Okay, granite. It forms countertops, gravestones, very hard igneous rock here that forms deep underground. It's got very, very nice sparkles to it. All right. Rock number 12 Was kind of a darkish grayish rock, and most of you hopefully would have noticed that it did have some holes in it, or some, like what looked like holes in it. This is a rock called basalt, right, which is a very, very common igneous rock. This is the most common, not only igneous rock, but actual rock on Earth. It makes up most of the ocean crust, and the ocean makes up 70% of the world, right? And rock 16, some of you may have guessed this. This is a rock that has a very recognizable name. It's called obsidian, Obsidian, obsidian. All right, and this is a rock that is very sharp. It actually forms sometimes called volcanic glass. It can also be used as back in the day, cavemen and before there was knives, and metal workers and things like that actually used to use this to cut through meat and as spears for their arrow tips and things like that. So very, very sharp, as you might have saw and point from that rock, and very shiny. Okay. So along with your observations, you should have 3 of them. None of these should have fizzed in acid. If any of them did, there was likely some remnants or something that was kind of coating it, but none of them should have fizzed in acid. So hopefully you have that written down as no for all of those. All right, now directly underneath this chart here, and if you don't have room, this can go on the next page or along the side of the page somewhere. I want we want to make some comparisons to the Grand Canyon rocks. All right, so underneath your chart, you're going to write these things here, and you can go ahead and skip a line between each of them. So you're going to write, how are these rocks, these 3 rocks here, which are igneous rocks, similar to Grand Canyon rocks? And you have those Grand Canyon rocks in that container, so you can kind of use them as the comparison there. And so come up with 2 things and how they're similar. All right. And then you need to come up with 2 ways that these rocks are different from the Grand Canyon rocks. All right, so 2 ways that they are similar. Think about, as far as, you can look at colors, you can look at textures for similarities and or differences. Think about what are, for differences, it's usually a little bit easier to come up with differences. And we can talk about this more tomorrow when I'm back if you're struggling to come up with either a similarity or a difference. But between you and your partner, see if you can come up with 2 similarities and 2 differences. So I'll have the teacher pause this here in order to give you time to write down your similarities and differences. Shouldn't take more than a few minutes. All right, so after you have that done, we're going to go ahead and go to a new page. And same title up here at the top. And while you are writing that title, or after you are done writing that title, you are going to need a few pages. We have 3 pages that we are going to need to glue into your notebook. The first one is going to be this one right here. It's the one that says magma versus lava on the top. So find that one. So make sure it says magma versus lava on the top of it. There's 2 sheets that kind of look like similar to each other. All right, so go ahead and glue in that one that says magma versus lava. Okay, go ahead and glue that in. And these notes are going to be ones that we're going to go ahead and write, or go ahead and you'll just have to write in definitions and also highlight your vocabulary. But go ahead and glue this in. The teacher can pause the video here while everybody finishes gluing in. So one of the first things that we want to talk about when it comes to Igneous rocks is what's down beneath our feet, and where does igneous rocks come from? And one of the first things for us to understand is this difference, albeit small difference, between magma versus lava. So magma is molten liquid rock that is beneath Earth's surface. Molten liquid rock that is beneath Earth's surface. Once you are done writing that definition, you can highlight. The word molten means like melted. Okay. So the word molten and melted kind of mean the same thing. So it's molten liquid rock beneath Earth's surface. Uh, Rock is normally solid at room temperature, right? Like on the surface of the Earth. But inside the Earth, it is very, very hot. And it's hot enough to actually melt rock completely. When it does that, rock gets a very like reddish, orangish yellow appearance. And that's what we've seen or are kind of used to seeing, in movies and in pictures. But what we're actually seeing usually is lava. Now, the lava is molten liquid rock that has erupted on Earth's surface. Make sure you highlight. So you can see the first part of the definition is the same, molten liquid rock. The only difference between magma and lava is where are they located. Magma is beneath the surface. Lava is above the surface that has erupted out of either a volcano or a crack in the earth, something along those lines. Okay, you can pause the video here. More time is needed to write those down. So now getting into Earth's layers, now that we understand that lava is above the surface, magma is below the surface, and really it makes no difference. Otherwise, they're made up the same material. It's that hot orangish yellow, reddish color to it. And as it cools, it'll turn different colors. But let's talk more about what's beneath the surface of the Earth here. So if you remember when we talked about the atmosphere of the Earth, if you remember we talked about layers of the atmosphere, the troposphere, the stratosphere, the mesosphere, the thermosphere, and exosphere. So there's 5 layers, from the one that was closest to the Earth to the one that's above the Earth. And we can go down into below the Earth and also find layers as well. They're a little bit more tricky as far as is kind of breaking them up because there's some overlap, but there are 3 main layers, and then there's some like smaller like layers that are sort of sub layers. So let's start off by talking about the outer main layer of the Earth, which is going to be the crust. So the crust is going to be considered the solid outer layer. Go ahead and highlight that. Solid outer layer of Earth. So it's solid, all right? There is no liquid part. There is no, what we're also going to be talking about, semi-solid, which is sort of like a, in between a solid and a liquid. So it's all solid. It's the outer layer of Earth. And it can have various thicknesses depending on where you are. So, roughly anywhere from 2 to 25 miles thick is kind of like the most that it can be. And sometimes people will even say it could be 0 miles thick because if you have a crack in the Earth's crust where magma comes up, technically that's part of the mantle, which is below. But generally it's very thin compared to the rest of the layers of the Earth. Now 25 miles might seem like a lot, but it's actually not when you look at the like inside of the Earth itself. It's very thin at places where magma comes up through the cracks. So places that would happen, as we're going to learn about, are called divergent boundaries. These are places usually underwater, so we don't see them as often. But these are places where the plates of the Earth are actually pulling apart, and so magma will come up between those pieces and spill over, and the crust is very, very thin there. All right. And then it's very thick at places like mountains. Underneath mountains, there's can be miles and miles of bedrock. So that's where usually where you'll find the 25 miles. Otherwise, on average, it's probably about 10 to 15 miles thick. Okay. So the crust makes up the bedrock, and we have heard this term bedrock before. We've talked about bedrock. Bedrock is the rock that makes up the Grand Canyon, and it's also sometimes visible at places like Morton, where we talked about, or in Mankato at the places that quarry the limestone, or up in Duluth. So there's places where the bedrock kind of peaks out, even in Minnesota here. So that's part of the crust. Okay, so it doesn't really include the soil. All right, now you have this picture. I'm going to have you go ahead and glue that in. So as you're gluing this in here, this picture here shows a lot of the layers that we'll be kind of talking about here and where they are. So the crust, which we just got kind of done discussing here, so you can see here it's listed as 0, to 100 kilometers. 100 kilometers is about 20, 30 miles or so. Like I said, every picture kind of varies, but you get the idea. So the crust can be very, very thin. It's actually just this dark brown structure, not the light brown that's underneath that. That's something else. The crust is only this dark brown structure. So you can see how the crust is actually pretty thin underneath the ocean. That's because the ocean crushes it. And it's very thick at places like underneath mountains where you have a lot of bedrock underneath there. And then, sort of in places in between, which is like where everywhere else is, would be similar to this right here. But the crust is just this dark brown structure here. The lighter brown structure belongs to something else. So the crust is actually the thinnest part of Earth's structure. So the other two main layers are going to be the mantle right here. So if you look at where the mantle starts right underneath the crust. All right, so it includes this tan layer, this orange, the two orange layers, the dark orange and the light orange, and then this sort of yellow layer here too. So all of 3 or 4 of those layers, technically, I guess 4, are considered part of the mantle. And the mantle is broken up into layers too. It's not all the same. The mantle is probably the trickiest one. And then our third one is called the core. So the core is the two gray parts here. We have an outer core and an inner core. So, but we kind of combine those together. So crust, mantle, and core are the 3 main layers. But as you're going to see, we can split that up into other ones. So I believe this will probably take you up to what you need to know for today. I'm not going to get started on anything else. If you're all done with this, you can just have a few minutes to yourself. Thank you, and I will see you tomorrow.